Welcome to Lesson 2 of the GAMS training. During this session, we will present a simple example taken from the GAMS User's Guide by Rosenthal. We recommend that you consult Chapter 2 of the guide, where the treatment of this example is slightly different. In this manner, you will become aware of the various ways to program a model. Our objective is to present this simple example in order to illustrate the different parts of a GAMS program. In this example, there are several plants, denoted by index I, that are producing a given quantity AI of a commodity. This commodity is sold on different markets, denoted by J, for which the demand Bj is known. Let's assume also that the unitary cost of shipping from each plant to each market is known and denoted by Cij. We want to find the quantity to be shipped from each plant to each market and denoted by Xij in order to minimize total transportation cost. In mathematical terms, the firm wishes to minimize total transportation cost denoted by Z. Z is simply the double sum over I and J of the quantity shipped multiplied by the unitary cost of shipping. The objective is to minimize this expression subject to the supply constraint of each plant, which states that the sum of each plant's shipment to all markets does not exceed the plant's capacity denoted by AI, and to the demand constraints, which states that the sum of all plants' shipments to each market satisfies at least the market's demand denoted by Bj. In GAMS terms, sets represent the plants and the market I and J, used as indices in parameters and variables. Parameters represent exogenous values that are known or given, such as the unitary cost of transport Cij, the plant capacity AI, and the demand in each market Bj. Variables represent value to be determined by solving the model, such as Z, the total cost of transportation, and Xij, the shipment from plant I to market J. Equations represent the formulation of the problem to solve and include the total cost of production, the supply constraint, and the demand constraint. As a general rule, it is necessary to proceed to the declaration of any element before using it. So since variables and parameters are in equations, they must be declared before writing equations. Similarly, since sets are used as indices, in variables and parameters, they must be declared before variables and parameters. In other words, sets must be declared at the very beginning of the program. The general structure of a GAMS program can be divided in three main modules: data, which covers the declaration and definition of sets, the declaration of parameters, and the data assignment. Next, the module model, which covers the declaration of variables and equations, and the definition of equations and the model to solve. Finally, the model solution, where we solve the model and display the results. We start with the declaration and definition of sets. In our example, as you recall, we have two sets, I and J. The set I represents the two plants where the commodity is originating. They are located in Seattle and San Diego. The set J represents the markets where the commodity is sold. There are three markets located in New York, Chicago, and Topeka. In mathematical terms, we would define the two sets in the following manner. The name of the set is followed by the elements of the set, Seattle and San Diego for the set I, and New York, Chicago, and Topeka for the set J. The elements are grouped in braces and separated by comma. In GAMS writing, it's very similar. Sets is a GAMS keyword and must appear before sets are defined. Note that in GAMS, the elements of a set are grouped within slashes rather than braces. Elements of a set are separated either by comma or by an end of line. When all sets are defined, a semicolon ends the statement sets. In other words, the semicolon signals that the statement sets has ended and anything following does not concern the definition set. Although it is not a requirement, you may want to add text to the set's definition, either to describe the sets or the elements. So the following writing is equivalent to the previous one. Note that we added canning plants to the set I, Seattle production site to the element Seattle, and San Diego plant to the element San Diego. We did not add any description to the elements of J to show that the text is optional. Also note that in this writing, we chose the end of line option instead of the comma to separate the elements of the set. In other words, the syntax for simple sets is the following. The keywords sets is followed by the set name followed by explanatory text, a slash to start the list of elements, the name of the first element followed by text, the name of the second element followed also by text, and so on until all the elements have been listed. A slash to end the group of elements in the first set. Same process for all the sets. Note that the items in italics are optional. In GAMS IDE, the different parts of the set's definition will automatically appear in different colors. GAMS keywords appear in bold blue. Set names appear in black. Elements are in green. Explanatory text for sets is in blue. And in black for elements. Do not be concerned if syntax colors appear differently in your GAMS editor. For example, the explanatory text for elements may appear in green instead of black. To summarize some main points on sets declaration and definition, GAMS does not differentiate between the plural or singular of keywords, so sets or set can be used indifferently as keywords. GAMS does not differentiate between capital and lowercase characters. You can use a comma or end of line to separate the elements of a set. And although explanatory text is optional, it is strongly recommended to add text for documenting purposes. We now proceed to the declaration of parameters. In GAMS terminology, a parameter refers to given data or exogenous variables. This is different from a decision variable or endogenous variables, which is referred to in GAMS as a variable. Parameters can be declared and assigned a value in the same statement or in separate statements. In the GAMS User's Guide, it is done in one statement. We do it in separate statement in this training to show a different way. Before we assign values to parameters, they must first be declared. In our example, there are three parameters: AI, which refer to supply from plant I, BJ, which refer to demand by market J, and CIJ, which refers to the unitary cost of shipping from each plant I to each market J. In GAMS, parameters are declared in the following way. Parameters is the keyword. Parameters defined over a set have the name of the set in parentheses following the name of the parameter. In our example, the parameter A refers to the capacity of the plants and it's defined over the set I of plants. Similarly for B and C. Parameters are separated by commas or an end of line. Note that when a parameter is defined over more than one set, the sets are separated by a comma. A semicolon signals the end of the parameter statement. Although it is not a requirement, text can be added to describe the parameters. The following writing is equivalent to the previous one. In our example, we added text to the various parameters and listed the parameters using an end of line. Similarly to the sets declaration, in GAMS IDE, the different parts of the parameter definition will automatically appear in different colors. The keyword parameters appears in bold blue. The names of the parameters appears in black. The explanatory text for the parameters appears in blue. In other words, the syntax to declare parameters is the following. The keyword parameter is followed by the parameter name. In parentheses, the name of the sets on which the parameter is defined is followed by explanatory text. Note that items in italics are optional. To summarize some main points on parameter declaration, GAMS does not differentiate between the plural or singular of keywords. So parameters or parameter can be used indifferently as keywords. And GAMS does not differentiate between capital and lowercase characters. You can use a comma or end of line to separate the various parameters. And although explanatory text is optional, it is strongly recommended to add text for documenting purposes. GAMS differentiates between three types of parameters: scalars, and tables. Parameters that are not indexed may be declared using the scalar statement. Parameters with two or more indices may be declared using the table statement. Both scalar and table can be declared using the parameter statement. This is how it will be done in this training. In the next session, we cover data assignment. In our example, the parameters' values are known. In the following tables, the values are presented as they appear in the GAMS User's Guide. The values of the parameter Cij, the unitary shipping cost in dollar per case, are shown in this table. We also know the capacity AI of each plant, expressed in cases, 350 for Seattle and 600 for San Diego. Finally, we know the demand by each market, also expressed in cases, 325 for New York, 300 for Chicago, and 275 for Topeka. There are many ways to enter data in the program. One way is to enter data one element at a time. This is called direct assignment. For example, supply from the Seattle plant can be entered as one entry. Note that when referring to a specific element of a set, the name of the element is put within quotes. They can be simple or double quotes, but the opening and closing quotes must be the same. Each assignment must end with a semicolon. Note that an assignment may include calculation. Cij is given in dollar per case. If we want to express the cost in thousands of dollars per case, we need to divide each item of Cij by 1,000. In GAMS ID, when one refers to an element of a set, the name of the element appears in red. On this slide, the parameters are assigned values one element at a time. While direct assignment is easy to understand and adequate for small models, it becomes tedious for larger models and increases the chances of making mistakes in entering data. When a parameter has two dimensions or more, data can be entered using the table statement. In our example, we can assign values to parameter Cij in the following manner. The keyword table appears first in the GAMS statement. C is the name of the table. It is defined over the sets I and j, which appear in parentheses. The first set represents the rows and the second set represents the columns of the table. So in our example, the row titles are the element of I, the producing plants, and the column titles are the element of j, the markets. Explanatory text can follow the name of the table, and as usual, a semicolon signals the end of the table statement. Calculation can be done at the table level for all the elements at once, if need be, by direct assignment. At this time, we pass rapidly over arithmetic operations. They will be covered in more details later. In our example, parameter AI and BJ must still be assigned values. This can be done by data entry by list, as in the GAMS user's guide, or by direct assignment, as we did before. In larger models, it might be useful to use a single table to assign values to all parameters. Let's put all the data into one single table. It consists in augmenting our original table with AI, capacity, as an added column, and BJ, demand, as an added row. In GAMS writing, we note that the column's title include not only the element of J, the markets, but also a fourth column titled supply of each plant. In the same way, the row titles include not only the element of I, the plants, but also the third row titled demand by market. In cases where the titles do not refer to a simple set, the symbol star is used. It indicates that the sets can be specified later. When writing a table, note that the column values must be aligned with the corresponding column titles as shown on the table. At least one digit must be aligned with the title. Also, no part of the value must appear under another column, or GAMS will not know to which column it should assign the value. We can then assign the value of each parameter based on the table content. Note that the same indices must appear on both sides of the equation. C being defined over I and J, the reference to the table must also contain I and J. The parameter A being defined over I, the reference to the table must also contain I. This is the case also for BJ. If the title of a column or row has not been previously declared, in other words, when the heading does not correspond to an element of a set, then the title appears in quote. In GAMS IDE, the different parts of the table statement will automatically appear in different colors. The GAMS statement appears in bold blue. The name and dimension of the table appear in black, and the explanatory text in blue. Finally, the data and the titles appear in green. We now take a closer look at the data assignment based on the table data. The first statement assigns to C only the elements I and J of the table data. The second statement assigns only the column supply to the parameter AI. And finally, the last statement assigns only the demand row to the parameter BJ. In other words, the syntax for defining a table is the following. The table statement is followed by the table name, followed by the sets in parentheses, or stars if the rows and columns do not correspond to defined sets. It is then followed by the explanatory text. The elements of the first set are the rows. The element of the second sets are the columns. And the values must be aligned with the corresponding column titles. A semicolon marks the end of the statement. Items in italic are optional. Next, we define the model, and we start by the declaration of variables. In our example, the variables are Xij, the number of cases shipped from plant I to market J, and Z, which is the sum total of shipping costs. In GAMS writing, we would have variables is a GAMS statement, and it must appear before the variables are defined. Next, variables are defined. They are separated by a comma or an end of line. A semicolon marks the end of the variable statement. Again, explanatory text can be added to describe the variables. So the following writing is equivalent to the previous slide. Explanatory text has been added to the variables, and an end-of line is used instead of a comma to separate the different variables. In GAMS IDE, the different parts of the variable declaration will automatically appear in different colors. The GAMS statement appears in bold blue. Variable names and dimensions appear in black, and explanatory text in blue. In other words, the syntax for simple variables declaration is as follows. The variable statement followed by the list of variables defined over sets, followed by explanatory text. And the semicolon marks the end of the variable statement. As usual, the items in italics are optional. To summarize some main points on variables declaration, GAMS does not differentiate between the plural or singular of keywords, so variables or variable can be used indifferently as keywords. And GAMS does not differentiate between capital and lowercase characters. You can use a comma or end of line to separate the various variables. Although optional, it is strongly recommended to add text for documenting purposes. It is possible to set boundaries for variables. By default, variables are free or unbounded. So, in solution of the model, they can take any value. In practice, the user might want to introduce bounds on certain variables in order to avoid inconsistencies. In our example, we are searching for the quantities to be shipped in order to minimize total cost. Certainly, negative quantities would reduce total cost, but this outcome would be inconsistent. The syntax to assign a lower bound is simple. GAMS attaches the suffix .lo to the variable name to specify a lower bound. In the same manner, GAMS attaches the suffix .up to the variable name to specify an upper bound. In our example, we would write this statement to specify that Xij must be positive. Next, we will declare and define the model's equations. Recall that in our example, we have three equations: one equation of total cost and two equations for the constraints, the supply constraint on each plant and the demand constraint on each market. In GAMS, equations must be declared being given a name before they can be defined. In GAMS writing, the declaration of equations is headed by the keyword equations, followed by the list of equations defined over sets in parentheses. Equations names are separated by a comma or an end of line. We have named our three equations: cost, supply, and demand. Finally, a semicolon ends the equation statement. Although optional, explanatory text can be added to describe the equations. The following writing is equivalent to the previous slide. Note that explanatory text has been added for each equation and an end of line has been used instead of a comma. In GAMS IDE, the various parts of the equations declaration will automatically appear in different colors. The keyword equations appear in bold blue. The equation name appears in black, and the explanatory text appears in blue. In other words, the syntax for equation declaration is as follows. The keyword equations, it's followed by the various equation names, the set or sets on which they are defined in parentheses, and the explanatory text. A semicolon at the end of the statement equation. Items in italic are optional. To summarize some main points on equation declaration, GAMS does not differentiate between the plural or singular of keywords, so equations or equation can be used. GAMS does not differentiate between capital and lowercase characters. You can use a comma or end of line to separate the various equation names. And although optional, it is strongly recommended to add text for documenting purposes. Next, we proceed to the definition of equations, the GAMS writing of their mathematical form. We remind you that at this time we will not cover in detail mathematical operators. We will do so in lesson 3 of the training. So in GAMS writing, the equation name in our example cost is followed by 2 dots, which signals that what follows is a definition of the equation. Next, the equation formula is expressed using relational operators linking the left and right-hand sides of the equation. The operator equal indicates that the left-hand side must be strictly equal to the right-hand side of the equation. The operator L indicates that the left-hand side must be less or equal to the right-hand side of the equation. Finally, the operator G indicates that the left-hand side must be greater or equal to the right-hand side of the equation. Each equation ends with a semicolon. In GAMS IDE, the various parts of the equation's definition will automatically appear in different colors. Everything appears in black except for the mathematical function, which are in blue. Again, we remind you that we will cover arithmetic operators and mathematical functions in greater detail in lesson 3. In other words, the syntax for equation definition is as follows. The equation name and the sets on which it is defined in parentheses, followed by a double dot. Next, the left-hand side and the right-hand side of the equation are separated by a relational operator. A semicolon signals the end of the definition. We now move to the model to be solved. In GAMS, the model is a set of equations that must be solved simultaneously. Model is a keyword. It is followed by the name of the model. In our example, it is called transport. The list of equations to be solved is set between slashes. If all the equations defined are to be included, the keyword all can be substituted for the list of equations. A semicolon signals the end of the model statement. Although optional, explanatory text can be added to describe the model. The following writing is equivalent to the previous slide. Note that explanatory text has been added. In GAMS IDE, the various parts of the model definition will automatically appear in different colors. The keyword model appears in bold blue. The model name appears in black. The explanatory text in blue, and the list of equations in green. We now move to the final step in the structure of the model, the solve statement. First, the user must specify to GAMS the type of models to be solved. The complete list and description of model options appears in section 9.2.2 of the user's guide, and we urge you to consult this section to learn more about various types of models. In our example, there are no nonlinear terms nor discrete variables. What we have is a linear programming type of problem, or LP. We also want to minimize the objective function that represents total shipment cost. This information must appear in the solve statement. The GAMS syntax for the solve statement is as follows. The keyword solve heads the GAMS statement, followed by the name of the model, transport, followed by the keyword using, which precedes the specification of the model type. The type of operation, in our case minimizing, must be specified, followed by the variable of the objective function. A semicolon signals the end of the statement. We have come to the end of Lesson 2, and for your assignment, you will write a GAMS program using GAMS IDE. Open a new GAMS file in GAMS IDE. Save the file in the same directory where you created your project in the last lesson. Call the file Lesson 2. Write the GAMS code that was prepared in the previous slides. At this time, don't be too concerned with errors. You will learn in the following lessons how to correct them. Simply pay attention to the various features just presented. Thank you for listening to Lesson 2 of the GAMS training.